Okay, here we go. 6-1, ratios and proportions. Okay, writing, by the way, a ratio is like a fraction. So writing a ratio as a fraction. I'm sure as soon as I write this, you're going to remember these if you haven't remembered them already. So first, a ratio is a quotient that you're dividing, quotient of two numbers or quantities. It doesn't actually have to be numbers. It can also be a quantity. It can also be written as a fraction. In multiple ways. There's actually 3 ways. I think a ratio while you're writing, I think a ratio, I don't know why, but like commercials all the time, like 4 out of 5 dentists recommend this, right? That's a ratio. Uh, such a ratio. So if I want to write these words, the words as a ratio, the ratio of two, two, 3. That's would be it in words. That's not how you write a ratio. But I didn't want to give it to you without saying what I'm trying to say. Okay, you could write 2 to 3. That's a ratio. You could write 2 to 3 like that, or you could write 2 to 3. They're all ratios. So actually, every fraction you have is a ratio. And like I said before, sort of kind of used when you want to compare like quantities. Here's what's important about a ratio. In a ratio, you have to be comparing. Well, let me write it. Actually, let me just write it out. You have to be comparing quantities of the same unit. They have to be the same unit, or else it's not a ratio. For instance, if you have 6 inches and 3 feet, that's not a ratio. You have to make them all feet, but you got to make them all inches. They have to be the same unit. Have to be the same unit to be a ratio. And I'm going to do a couple examples. Okay. Examples. A little look at ratios before we start really putting together. Okay, so here's the directions. Write a ratio of each phrase. Sort of like what I did above when I wrote out the ratio 2 to 3 in words. Write the ratio in 3 different ways. We're going to practice all the ways we just saw above. Hold on a sec, wait, write that down. Oh, before I forget, I just saw I got some classes. They finally gave me some classes. I don't have all of them yet, but I do have a developmental math 2. But I don't know if you guys are gonna like it. Let me find it. Okay, my development math 2 they just gave me is session D. So it starts in October and it ends in December. So it's like a summer session, real short. But I do have one in case you're interested. I'm expecting to get one more. I
Did
don't know
the
when.
white, I'm
Your screen
sorry,
got
did the
smaller.
whiteboard, yeah,
Oh.
it like got cut in half.
Oh yeah, because I'm reading something. It's all right. I'll bring it back. I'll bring it back. I'm reading about I'm trying to read my class. Anyway, it is in school though. So if you're interested, developmental math 2 is October to December, and it is in class. When is it? What's the time? What's the time? What's the time? It is Tuesdays and Thursdays, 8 a.m. to 10:40. Woohoo! Yay, nice and early. Okay, I'll bring it whiteboard back. Anyway, some people have been asking me. I just saw my schedule. There you go. I am expecting to get one more. I don't know when, but I see you guys ready. So hold on a second. Okay, so first one, the ratio of 3 parts of gasoline to 7 parts of gasoline. Notice they're both say the same thing. They both have the same units. They are both parts of gasoline. So we can just go right to a ratio. We don't have to change anything because they're the same unit. So the 3 ways we can write it is 3 to 7. That's one way to write a ratio. We can write 3 to 7 that way, or we could write 3 to 7 that way. As long as they're the same units, you're fine. The reason they have to be the same units is that the actual ratio doesn't have a unit. So they'll be the same unit. You don't have to write the unit. If they're not the same unit, you can't write it as a ratio. And you're going to see it in this one too. The ratio of 40 minutes to 3 hours. Now, this one does not have the same units. We have minutes and hours. Can't happen. So either it doesn't even matter which way you convert it. You're going to have to convert minutes to hours or hours to minutes. And you pick whichever way you like best. I think it's easier to go from hours to minutes because we know how many minutes are an hour. So 1 hour is 60 minutes. So 3 hours have to be 60 times 3, which is 180 minutes. Great. So then what we're really comparing is, this is really what we're comparing, 40 minutes to 180 minutes. And notice now that they're the same units, I can make a ratio. By the way, because it's going to remind me right here, ratios are also just like fractions. You can simplify them. Okay, so I'm going to start with a fraction then. So 40 over 180, because I'm going to simplify it. I can divide by 10, that they're gone, and then I can divide by 2 over 9. So that's my ratio, 2/9. That means I can also write it as, so I have 2/9 I have 2, 2, 9, and I have 2, 2, 9 written this way. They're my three
Do
ratios.
we always have to simplify like this?
Always, it's just like a fraction. Yep. So I tend to do the fraction first so I can simplify it if I have to simplify it. Yeah, you can't do 40 to 180. It's like, you actually have to simplify it. Yeah. And notice there's no units on the answer because they're in the same units. We don't need units. Three. The ratio of 15 inches to 2 feet. Again, we can't do 15 to 2 because they're not the same units. You can convert any way you want. I think the easiest way is to take feet and make it inches because 1 foot equals 12 inches. So 2 feet would be 2 times 12, which is 24 inches. So once we do our conversion, we can rewrite it. Our ratio is really 15 inches to 24 inches. And by the way, if you go backwards, let's say you decide to convert inches to feet, at the end, you get the same ratio. Doesn't matter which way you convert, at the end, you get the same ratio. Okay, so I'm gonna start with fraction because I think this one I can simplify. I can divide by 3. So 15 over 24, I can divide 3, 5 over 8. Okay, so my 3 ratios are 5 over 8, 5 to 8, or 5 colon 8. It's also 5 to 8. Any questions yet, anybody? The biggest thing is making sure you get the same unit. Beside comparing words, have wordings to compare, you can also compare things in geometry. You've probably done this way back in high school before. So we're gonna look at a triangle. Like it doesn't have to be a triangle, it could be any geometric figure, but we're gonna look at a triangle. And I have the sides. This is 8 centimeters. No, I have meters. Doesn't really matter. 6 meters. They're all the same units, which is good. I don't have any conversion. They're all the same units. So I have my triangle and my sides are 8 meters, 6 meters, and 10 meters. Just a little side note, always remember the hypotenuse. This has nothing to do with what we're talking about, what we're teaching, but I always use things as a teaching moment. The hypotenuse is the longest side of the triangle, which is always opposite the right angle. So this always has to be the longest side. I can't help but say it. It's a teacher thing. All right, so what do we want with this triangle? So we want to find the ratio of the shortest side of the triangle to the longest side. And we're still running it 3 different ways just to practice. Okay, shortest side, 6. Longest side, 10. Simplify. Divide by 2, 3/5. So I have 3 ways I can write the answer. I can write it as a fraction. I just did 3/5, 3 to 5, or 3 colon 5, which is 3 to 5. Again, notice there's no units. They'll never have a unit. because you already took care of the units. You can compare like rectangles and squares, all kinds of things. We're going to do the same triangle for number 5. I'm going to scoot this up just so I can keep that triangle in our visual. There you go. I'll give you a few minutes. I see you're still writing. So basically what we're doing is we're comparing geometric parts or parts of a geometry figure. That's what geometric parts means. 5. Use triangle and number 4. So same triangle. This time we're going to find a ratio of the longest side to the triangles perimeter. So this time we're going to find the ratio of the longest side to the perimeter of the triangle. So number 1, we got to find the perimeter. How do you find the perimeter? Okay, remember? I'm going to add all the sides up. So perimeter is 6 plus 8 plus 10. So add up all the sides. That's your perimeter. That would be 24, I believe. Let me add again. Yep, 24. So now we can do our ratio. Our ratio, I'll move this up a little bit because now we have our perimeter. Our ratio was the longest side to the perimeter. But we can simplify that too by dividing by 2, and we get 5/12. Remember too, I should probably mention this too, when you do a perimeter, it's still meters. So it's still the same unit. We didn't change the unit. Area would be different because area would be a square. So you wouldn't be asked for area, but definitely perimeter. And so our answers would be 5/12, 5/12, 5/12. The 3 different ways you can write the answer. You don't always write the answer 3 ways, but just practicing. Okay, any
What if they say that they want your answer in 3 different ways?
That's what you do. You do all 3 of them. They might. And then some of them that might just say right as a fraction or something like that. I was trying to look at your homework before everybody got here. I didn't get that far through it to see how I was trying to see the exact thing, how they ask you for the question. I didn't get that far. I guarantee if I have a couple that say write it 3 different ways. There's probably a few that say just write the ratio. You can pick any way you want. It'll probably take all different ways, but just read it. Make sure you read directions what they ask. All right, that's ratio. We're gonna add a little bit to it. So ratio is a fraction, right? So there's a special kind of ratio that you use a lot, and it's called a proportion. Proportions. They're like one of my favorite things. I use proportions for a lot of things in math, and you can use proportions for a lot of things in math. Okay, so why is it under a ratio? Because a proportion shows 2 mathematical ratios. Oh, not ratios that are equal. That's what makes a proportion. They're equal. So remember they're equal, right? So this would be a proportion. 1/3 is equal to 2/6. That's a proportion. There are two ratios. And by the way, they're always fractions. Two ratios or two fractions that are equal to each other. That's a proportion. Maddie, your cat is like right up to your face. It's cute. It's too
I
cute.
know, she just kept getting closer and closer.
I've been watching her creep up, creep up, creep. Now she's like in your face. It's cute.
She just
Hey.
wants to be included, you know?
I love it. I love the animals. You can't get that when you go to school. You know, you get the whole house feel. Okay, so one thing with proportions, normally you be given something like this, and you have to find the missing part of the proportion. So usually we are going to find the missing part of a proportion. And that's what we're going to do next. We're going to have a proportion, two ratios that are equal to each other, but we have to find one of the parts. While I have this up, I will show you one way to do this one, and I'm going to show you another way to do this one. But I'm going to come back for a minute. I want to give you one more definition. Okay, cross products. With proportions, we can use cross multiplying to find the missing part. Actually, there's really two ways to do it. Most of the time, cross multiplying, everyone just sort of goes across multiplying cross products. It's awesome. It works every single time. So I'm going to go back after you write that down. I'll wait. I'm going to go back to this proportion I wrote up here. And I'm going to show you the two ways I can solve for that. So I'm actually going to write it again. 1/3 is equal to x over 6. Now, we already know the answers too, because we already did it already, but I want to show you how the two ways you can do it, because some of them are not going to be so obvious. I'll write it twice, because we're going to do it twice. But the one thing I look out for with proportions is I look to see if I could just multiply. For instance, looking here look at 3 and look at 6. What could I multiply 3 by to get 6? 2, right? So what I could just do is I realize I multiply this by 2 to get 6. So I have to multiply this by 2. So I know x has to be 2. 1 times 2 is 2. So you can look for like some length that way. Can I multiply one of my parts on one side by something to get the other side? And we can use that to find our answer. That's one way. You can't use it all the time. And then of course we have cross products or cross multiplying. So cross multiplying is this. You multiply across. So 3 times x is 3x equals, always equals. And then you multiply across the other way. And it equals 6. 6 times 1 is 6. And then you solve the equation, divide by 3, and x is equal to. So 2 different ways to get this particular fraction answer, or sorry, proportion answer. This way you can't always use, the first way you can't always use, the second way you can use for everything.
Can you do another one of those? The second way?
Oh yeah, I have a whole bunch coming, so you're good. That was just an example. We're actually gonna do I got a whole bunch of them. It's almost like, I know my students, they're so funny sometimes, but my high school students, they say, oh, look, it's a butterfly. They're like, okay, so they're like, here's the head, here's the body. It's a butterfly. That's my students. But I love it. So it does look like a butterfly, right? My students teach me things all the time. I'm like, I never thought of it as a butterfly before. There it is, it's a butterfly. Or a dragonfly. I guess there's more dragonflies down here than butterflies. I see dragonflies all the time right now. Okay, so let's practice. We're gonna do a whole bunch of them. If my students don't realize, we teach you, but you also teach us too. I learn things every time I teach. I could teach something for like 20 years that I haven't taught 20 years, but 20 years, and all of a sudden one student will say, hey, can't you just do that? And I'm like, wow, never thought of it that way. So it's amazing. Okay, so let's look at 6/8 is equal to, now I'm going to make the x in the bottom. Doesn't matter what the x is. 36/x. It doesn't have to be an x either. It can be a y or whatever, a variable. So we're going to look at this one. I did it on purpose, so we can do it two ways. So the first way, I'm going to write two ways in, so we do it both ways. The first way I see, and if you don't see it, it's not a big deal because we can cross multiply, but let me change my color. I can multiply this by 6, and 6 times 6 is 36, which means I can multiply this by 6. That means x had to be 8 times 6, x had to be 48. But if you don't see that, because a lot of students don't see that, they go right to cross multiplying. That's what we're going to do. So we're going to go, by the way, just get in the habit of doing the same direction. If you skip around, like, I don't know, there's something about being the same routine. So whatever way you want to start, I always start this side. I don't know why. I always start with that diagonal. I don't know why, but pick which way you like. So we got to multiply this. 36 times 8. 8 times 6 is 48. 8 times 3 is 24. 25 times 6 by 7, 28. Okay, so it's 288. Right meter. 288 is equal to, and now I'm going to do my other crossway. Across. Basically, one's on top to one on the bottom on the other side. So one on top to the one on the bottom of the other side, both ways, equals 6x. And then we would divide by 6, divide by 6. Okay, so now we have to do this 288 divided by 6. Okay, how many 6s are in 28? That'd be 4, which is 24. I have 48 left, and 8 times 6 is 48. And I get also x equals 48. I just had a little bit more math work, but it's the same answer at the end. So I'm going to show you how you can't always use the first way. I wish it was that easy because then you wouldn't have to do all the math, but not that doing math is bad, but here's one we can't do the first way. 9/10 is equal to 117/x. So why can't we do it the first way? Well, because as much as you'll try, there is nothing you can multiply 9 by to equal 117. At least I don't think so. Oh, maybe there is. I think I'm wrong. Because there is, I just thought about it. Never mind, I take it back. Okay, 117 divided by 9. We can do it. 1, 9, 27, 3. It is, it's time 13. I take that back, I'm wrong. Okay, so which means I can multiply the denominator by 13 And if I get that, that means x is 13 times 10, which is 130. Wow, I wrote that problem thinking you couldn't, and I did. I had to think about it. Okay, so let's do it the other way. 9 over 10 equals 117 over x. So like I say, I always do the same routine. I think doing the same routine will keep you from making a mistake. So once you do them always the same way. So 10 times 117 is 1,170 equals, and then we're going to do our other crossway. 9 times x is 9x. I'm going to divide by 9, divide by 9. Okay, so long division. Okay, how many 9s are in 1? None. How many 9s are in 2? 11. 1. 9. 2 left. Bring down to 7. How many 9s are in 27? 3. Minus 27, but we still have a 0 left. That means I have to do a 0, and I get 132. X equal, 130 as well. 130.
Mrs. Garrett, why are, maybe I missed it. So why do you divide by 9? I'm sorry.
Oh, divide by 9? Because 9 is with the x. Like this. We want it, my pen's not working. We want to get to x. So how do we get to x? We got to divide 9 off.
Okay, thank you. Sorry.
Oh, no, you're fine. Don't be sorry. It's good. Any other questions? I'm going to add some algebra to it next. Because most of the time, that's what we use proportions for algebra. And then we can't do it the first way for sure. We can only use cross multiplying. Okay, 3. 2x plus 1 over 7. You knew algebra was coming. You knew that, right? X minus 3 over 5. Okay, there really is no way to get ones together. I can't multiply 7 by something to get 5. So there is no other way to do it the first way. We had to go right to cross multiply. I just want you to be really careful. So watch what I do with cross multiplying, because a lot of people like to take a little shortcut and they tend to get it incorrect many times. So this is I really want you to do it this way. Cross multiply. I want you not to multiply them. I want you to write them down as like distributive properties. So 7 times x minus 3, just like that. Take that one extra step and write it down just as like what it is. 7 times x minus 3 equals. Yes, the number goes in the front, right? So equals 5. Whoops, sorry. Equals 5 parentheses 2x plus 1. You want the number in the front because we're going to have to distribute it. So always put your, if it's just a number, you have to always put that in the front before the parentheses. And now we're going to do algebra. So we're going to distribute 7x, distribute minus 21 equals, distribute the other side, 10x, distribute plus 5. And then I'm going to pause here just to see if you guys are okay having questions on what I've done so far. Very good. Okay, so now we have a regular equation, algebraic equation. So we're going to solve for x. So I don't know if I've told you this or not. I think I have. But when you have variables on both sides and numbers on both sides, I highly suggest that you always get your x's together first. Subtract 7x, subtract 7x. Why did I subtract 7x? Because you could subtract 10x, but I like to keep it as a positive x instead of a negative x. It's no big deal. Whatever one you like. Be really careful right here. See that negative 21? That has to come down as a negative and then plus 5. So that comes back down and that comes back down. Now we got our x's on one side. We're going to subtract 5 to get all our numbers on the other side. So 3x is equal to negative 26, because they're the same sign, we add them and keep the sign. So we're gonna divide by divide by 3, divide by 3. Now, 3 times, there isn't anything times 3 that's negative 26. So this is our answer. X is equal to negative 26 over 3. You can leave it like that if it, now your program will ask you probably a couple different things. They'll say leave it as an improper fraction. They might say leave it as a mixed number. So if it's a mixed number they want, how many 3's go into 26? 8 times 3 is 24, so 8, so negative 8. How many are left over? 2 out of 3. That would be your mixed number. That would be your improper fraction. It depends on what they ask you for. They could also ask you for decimals, and then you would divide them like we just did last chapter. And this would be a repeating decimal, this one. Any questions on that one? We're gonna do another one like that. 4. We have x minus 5 over 3 is equal to x plus 2 over 5. So proportion, we can cross multiply. Write it as a multiply problem first. 3 times both x plus 2 equals, and then I'm going to do my other way. Let me circle this way. And then we're going to do 5 times parentheses x minus 5. Then we have it set up so we can distribute and solve. So distribute 3x, distribute 3 times 2 is 6. That's my one side. Now distribute my other side. 5 times x is 5x. And 5 times negative 25 is minus 25. Sorry, negative 5, ahead of myself. 5 times negative 5 is negative 25, which is minus 25. Okay, I'm going to solve for x. So I'm going to do my x's first. I'm going to subtract 3x, just so my x is not negative. That's just my preference. You can do any way you want. I just suggest doing the x's first. Plus 25, because I have my x on the right, so I want my numbers on the left. X equals, okay, 25 plus 6 is 31. And then I want to solve for x, so I need to get rid of the 2. So I'm going to divide both sides by 2. Why do I divide? Because they're being multiplied 2 times x, even though we don't write times. And then that's not divisible, although I could put it as a decimal. So we can write it different ways. So it can be, if they want improper fraction, it'd be 31 over 2. Or if they want a mixed number, okay, so how many 2's go into 31? Well, 15 times 2 is 30. So 15, that's 30, and I have 1 left, 15 and a half. If they want decimals, since I have this already, I can go without having to divide. I know it would be 15.5. It depends on what they ask for. Okay, so I have 2 I want you to try after you guys get it all written down. I'm going to start with a little one, and I'm going to give you one like this after, just to give it a try, see how you do. Let's try it. Okay, so 5. So this is my little one. 9/14 is equal to x/70. Give it a try and see if you can find x. Doing it, don't look unless you're ready. I'm actually gonna show you. This one can be done two ways, so I'm gonna show you two ways. Okay.
You know, it's funny, I was doing it, I was cross multiplying first. And as I was cross multiplying, I realized I could have just done it that way.
That's always how it works. That's always how. I only really the reason that I know it because I wrote it. I knew it could do both, but I don't know if I would see it just sort of looking at it. I might just go right to multiply, cross multiplying too, which is nothing wrong with it. X is equal to 630 divided by 14. And then we do the division, you'll also get 45. So kind of just where you see it. How we do? Yeah, Maddie,
Ms.
people,
Garrett, you want, Ms. Garrett, you're saying that there is situations where that won't work, correct? That
Yeah.
shortcut?
yeah, like if I do something like this, 9/14 equals x/13. Can't do it. There's nothing I can multiply 14 by to get 13, right? And then you just do cross multiplying. Make sense? Yeah. So that would be one you put in. Okay, now let's do an algebraic one. See how you do with this. 6. X plus 4/5 is equal to x minus 1/4.
Yeah, I messed mine up somehow.
Okay, so look at all the steps I have, see if you can figure it out. If not, ask me. What number did you get, Joshua?
I got -1. So I guess the third step there is where I messed up. So where you did 4x minus 4x,
Yep,
I did 5x minus 5x.
okay, I could do that. Hold on. Equals 16. Okay, so minus 5x, which is nothing wrong with that at all. -5 equals, did you have -x plus 16?
Yeah, I have -x plus 16. Yes, ma'am.
And you have -5 equals -5.
Yes,
sorry.
ma'am.
Okay, then subtract 16. Subtract 16. So this makes -5 and -16 makes -21 is equal to -x. And then you would divide by -1 to make them the x positive. So x is equal to 21. See if that helps.
Yeah, I found my problem. So
Okay.
my -5 right there, for some reason I wrote a -15. So
Yeah, and that's really easy to do. Yeah, that's really easy to do. But it is, there's nothing wrong with what you did, but see how that negative at the bottom, the reason I always say try to make it positive, because I don't know, some people mess up with this negative on the bottom. If you try to get the x to be positive, that's why I did subtract 4 this time. I knew if I did 5 minus 4, I get a positive x. It sort of makes it a little bit easier to do. It doesn't really matter. But that's just my thing. I like to make my x positive and not negative. Hey, any other questions? You all right?